Hi, AT from CNC at Home. For a couple of years now, actually 3 or 4 years, I've had a chunk of wood that I cut while I was out doing some tree falling. And I cut a disc about, I don't know, 2.5 inches thick or so. And I had a friend of mine run that through a surface planer and he smoothed out both sides of it real nicely. So it was flat and the edges were parallel. And the intent was to make a cribbage board. Since then, I've purchased my little Genmitsu 3018 Pro router. The problem was, or is, it's not big enough to handle this chunk of wood. It's about this side. I'd show it to you, but this is actually after the creation of the cribbage board. So if I showed it to you now, you'd know what the cribbage board looks like. Anyway, trust me, it's bigger than the 180 millimeter Y travel on the 3018. So that kind of brings in an issue. Also, the thickness of this thing is a little bit too thick for that machine. Not too thick, but enough too thick where it causes some issues in the Z travel. The X travel, not a problem, it fits there. However, there are clamping issues because you have to have enough room to position your clamps in the channels and get everything locked down. So there were several physical limitations that had to be overcome. I ended up generating the G code for the actual holes for the cribbage board. It's a 3-track cribbage board, and I coded all of that manually. Now, when I say manually, I did use the computer to help me. I wrote some formulas in Excel and had it generate the G code based off of those formulas. So how did it make G code? I programmed that in as well into cells. It said, here's the G code I want. Positions for these holes were based off of these calculations. And as you'll see, it turned out great. Again, the problem is the machine's not big enough to do the full circle, to get all my 120 holes in a big circle at one time, because the Y travel wasn't great enough. So I was going to have to do this in 2 passes. The other issue, as I'd mentioned, was the Z travel of the router bit. The thickness of this piece of wood plus the depth of the hole, you have to add those together, because then that determines how high you have to have that tool to clear your material. Anyway, the thickness of the material plus the depth of the pocket that I wanted to make, I have to be able to get up and over the top of the material. The issue was I was out of Z travel to do that. So I put the Z up literally to its 0 and then back down 1 millimeter, because that's my little safety zone. And then from there, I made the tool come down to be about 2 millimeters above my working surface. So that was my movement clearance. And then I came in and I did half the pocket. And we'll see that in the video. It comes in, does half the pocket, and I had it stop. When I had it stop, I manually moved that Z gantry up, again, to almost its Z limit, upper limit, and I pulled the tool down so that the machine still thought it was down at minus 12.6 millimeters. And I brought the tool down, got everything reset up, and then ran the second half of the program. And that worked out well. So anyway, so that was the project. I also put this over on the LE5040 and did some burning on the top surface. So I put a couple things on there, put a double skunk mark, a single skunk mark, marked where the starting point on the board was. And I also took the idea that my friend had about engraving pictures of my children, and I did that with the laser and just ran those in through the Lightburn software, sized them up, positioned them, and used the laser to cut those into the cribbage board. To do the pocket, I did not code that part by hand. This is something that I designed up in Fusion 360. And I will show you the images that I captured from Fusion 360, and I'll also do a quick simulation of cutting this pocket out in Fusion 360. and I'll have that run along with the actual cutting of this pocket. See if I can synchronize them somewhat. It's kind of interesting to see that the cutting of this in the simulation mirrors exactly what's happening on the machine. And so that gives a real nice preview in a much faster time of what the cut's going to actually do and what it's going to look like. So I did go through several simulations and changed a few parameters to get the cutting to be more to my liking. So that's the project. I hope you enjoy the videos.
Oops.
Hi, I'm AT from CNC at Home. If you like our content, help support our channel by clicking on subscribe and liking our videos. Thank you for watching this video. Have fun with your CNC at Home projects.